So what do we got here? We got root theorems. Looks like I got about half of them marked off. Alright, so number 2, you're supposed to list the possible rational solutions according to the rational root theorem. And I just teach this as factors of A, which is the first number you see, over factors of C, you know, for constant. A is always the first thing, C is just a constant. So, I wrote that backwards. Factors of C over factors of A. So anyways, factors of 24 are going to be plus or minus 1, plus or minus 2. I feel like 3 enters 24. Plus or minus 3, I know 4 does. Plus or minus 4, 6 does. 8 does. That was 3 times 8 is 24. 4 times 6, 2 times 12, and then 1 times 24 itself, over the factors of 3, which are plus or minus 1 and plus or minus 3. So that was a lot of fun. And here's the fun part. You got to rewrite everything. We got to go through and we got to divide everything by that 1, which is going to be the entire list again. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, 6, 8, 12, and 24. I don't think my camera's actually facing me, is it? I don't think it was. Alright. Now, after we go through and divide everything over by the 1, we got to go through and divide everything by the 3. So now as I do this, I'm dividing by 3. 1 over 3 is a third. 2 over 3 would be 2/3. 3 over 3 is 1. 4 over 3 will be new. 6 over 3 is 2. 8 over 3 is new. And that should be all of them. 12 over 3 is a 4, and 24 over 3 is an 8. So yeah, those are easy. They are. Do kids forget how to do them? Every day. Every day. Alright, next one I got bolded is number 5. What are the real and complex zero roots of the function? Factor the polynomial over the complex number system. Look at the graph to find real zeros. So let's just look at the graph. I got stuff in there, so I got to clear mine out. Every one of these actually would have factored by grouping. I think. No, this one wouldn't have. Unless I have a typo, which I might. We're about to find out. Do a zoom 6. No typo. Cool, I got 4 nice zeros from this graph. Look at them. I got -2, -1, 1, and 2. So that's cool. That means the last 2 are imaginary. So from the graph, x equals -2, -1, 1, and 2. And by the way, this tells me some factors. If x is -2, the factor is x plus 2. If x is -1, the factor is x plus 1. If x is 1, the factor is x minus 1. If x is 2, the factor is x minus 2. And we're going to find the rest of them by using good old synthetic division. So I grab a number from my list. I'm just going to use the -2, throw it out front. Be careful about placeholders on these. There's an x to the 6th. There are no x to the 5ths. There are no x cubes. Remember that? No x cubes. No x to the 5ths. There are no x's, and then there's a 36. And the acronym on this was DMA. Drop, multiply, and add. And we multiply, and we add. And we multiply, and we add. And we just keep repeating that process until we're done. Okay. Now, I notice a couple of y'all, when you do your synthetic division on the next step, notice I don't go all the way to the end. because that's a remainder. I'm not worried about a remainder. I'm worried about the constant. Anyways, this time I'll do -1. I drop, and I multiply, and I add, and I multiply, and I add, and I multiply. Make sure I'm not making any mistakes here. Doesn't look like I am. And I multiply, and I add, and I multiply, and I add. Sweet. 2 to go. And then I gotta do something else. This time I'm a 1, drop, and multiply, and I add. One more round. I'm all the way at the 2. I drop, I multiply, and I add. I multiply, and I add. I multiply, and I add. Alright, so I've pulled everything out. What I've done is I've reduced this from the 6th-degree polynomial to a 2nd-degree polynomial. Remainder constant xx squared. I am left with x squared plus 9. I must set it equal to 0 because that's where the last 2 zeros are. So x squared is now equal to -9 by shifting right, which means x is plus or minus the square root of a -9, which is simply plus or minus 3 imaginary numbers. Now, if -3i is a 0, x plus 3i is a factor. If 3i is a 0, x minus 3i is a factor. Alright, my phone just went off. I'll be right back. So, you need to realize why I did what I did. Why did I do synthetic division 4 times? I did synthetic division 4 times to reduce the polynomial to a quadratic. Like this is x cubed. You only do synthetic division once. And then you'll be a quadratic. And you can either do the quadratic formula or maybe you can do what I just did. But that's the gist, to get down to a quadratic. Alright, I've got number 6. Number 6 looks scary. Lots of big numbers, right? It ain't scary. By the way, notice it's a x to the 4th. I'm going to do synthetic division twice because if I can spell, that reduces it to x to the 2nd. And that's the goal, get down to a quadratic. A lot of kids struggle with that idea. They're like, why do we keep going? Because you have to. You just have to keep going until you're a quadratic. Stuff is easy peasy, lemon squeezy. Anywho, I typed everything in. It's going to zoom 6 it. Alright, what do I have here? I know that I've got one nice 0 add. It looks like 5, right? This one is probably something like -2/3. So I'm going to go to y equals. I don't know for sure. I'm going to put a 0 in there. So now I can use the intersect function. Second trace 5 all day long. And just get your cursor close. Pay attention. There she is. Then press enter once, twice, thrice. And no, I was wrong. That's -0.6. That's what that is. Okay, so which would be -3/5. So from the calculator, x equals 5, or 0.6, which by the way is 3/5 because it's 6/10. You know, switch over to fractions. Let's pull out the easy one first, which is a 5. coefficients are 20, negative 148, 269, negative 106, negative 195. We're just going to follow our acronym DMA. I'm going to drop the 20. 5 times 20 is 100. Negative 148 plus 100 is negative 48. This is going to be negative 240. We're going to add and get 29. 5 times 29 should be 145. And then we're going to add. That's going to give me, I think, 39. Seems legit. And then we're going to multiply. And yes, everything worked out. We got 195. Got a remainder of 0. And this time we'll repeat the process with 3/5. Alright, to do 3/5 of 20, you multiply by 3, that's 60, divide by 5, that's 12. Negative 48 and 12 is negative 36. Again, we're going to multiply by, lost my train of thought here. Multiply by, something seems wrong here. I guess I'm just having a brain fart here. Anyways, if you multiply by 3, you get 108. Divide it by 5, and you get something pretty bad, don't you? I was hoping it'd work out where you didn't have all these fractions, but it's not. 3/5 times negative 36, it's going to be negative 108 over 5. Now we have to add to that 29, which is going to be 145 over 5. Seems right. And if we put those together, what do we get here? 33/5? That's what it has to be. Alright, we're going to turn around and we're going to multiply that by a 3. And divide it by 5. And I feel like I've made a mistake somewhere. That's 99/25. Let me pause this and see what the I'm a dum-dum. That's the problem. That was negative 3/5. It's negative. I'm an idiot. There's my problem. Please don't be offended by me calling myself an idiot, by the way. That's a negative 12. That's going to be negative 60. Alright, now we're getting somewhere. 60 divided by 5 is 12 times 3 is 36. So we got negative 36 there. What's our sum here? I done lost my place. Is it 7? That doesn't seem right. 60 divided by 5 is 12 times 3, positive 36. There's my issue. And then 29 and 36 is going to be 50, 65? 65 it is. 65 divided by 5 is 13 times 3 is 39, but it's a negative times a positive. There we go. 0. So what I've done is I've reduced it down to a quadratic because this is my remainder, my constant, my x and my x squared. I have 20x squared minus 60x plus 65. I'm going to set it equal to 0. I really don't want to try to factor that thing. It looks to me like everything's divisible by 5. So I'm going to pull that 5 out. That's going to give me 4x squared minus 12x plus 13. And I know, based on looking at the graph, that that thing is not going to factor. Like, the other solutions are not real. Or they're just really bad and they're somewhere else. And I also haven't seen the whole graph. That's actually worth looking at. Let's go back about negative 30 units. Let's go forward about 20. See what kind of crazy answers we have still before I just make a conclusion. Yeah, the other solutions are not real. So we're going to do the quadratic formula. A is going to be 4, B is going to be negative 12, and C is going to be 13. And it's x equals negative b plus or minus square root b squared minus 4ac all over 2a. Alright, so what do we have? We have 12 plus or minus a square root. This is 144. 4 times 4 is 16. Times 13 is 160, 208. So I got 144 minus 208, which is negative 64. Both pieces over twice of 4, which is 8. Now notice, I'm not going to take that negative 64 and divide it by 8. I'm going to think about this as the imaginary root of a positive 64, which is 8. Okay? Now, 12 over 8 reduces down into, they're both divisible by 4, 3 halves, plus or minus, let's see, we have an 8i over an 8, and we do a little bit more reduction. We know that 8 over 8 is 1. And there's your other two answers. Now, fun part, you were supposed to factor this thing, weren't you? I feel that you were. So we have a 0 at 5, factors x plus 5. We have a 0 at negative 3/5, the factor is x plus 3/5. Here, these get interesting, just remember change your signs. Positive 3 halves, so x minus 3 halves. If I do the plus the I, minus the I, and I ran out of room, so I'll put it here. Still negative 3 halves. If I do minus an I, plus an I. Ta-da! Now, complete factorization of that one. I think there's 2 left to do. 9. Your instruction set was list 2 more roots of each equation. Okay, so this is Milbrath-Math's ugly root theorem. If 2i is a 0, its conjugate, negative 2i. We think conjugates is a 0. And if root 7 is a 0, negative root 7 is also a 0. It's wrong, there's 3 to go. Rewrite in STD form. So what I'm going to do is I'm going to do 2 distinct operations here. I'm going to figure out this piece and that piece. This is easy, that's distributive property, 3x squared plus 3x. Now this one's going to take some work. I'm just going to draw a box. You don't have to draw a box. You don't. I know some of you don't like drawing boxes. I'm amazed you guys pass geometry because you don't like to draw. Or you like to doodle. You just don't want to draw what somebody tells you to draw. Anyways, we'll fill out the little box. X times x has always been x squared. X times negative 1 is minus x. X root 2, looks like my tracking's off here, minus x plus 1 minus root 2 minus x root 2 plus a root 2, and then a radical times itself is a number inside. Positive times a negative is negative, yada yada yada. And there we go. Let's see here. Stuff's going to cancel out. Those two annihilate each other. Those two annihilate each other. And this piece, what's left here, is x squared minus 2x and then minus 1. So now it's not so bad, is it? Alright, let's do another box here. Sorry I'm so jittery this morning. My children decided to wake up at 3 a.m., so I ain't slept a whole lot. Alright, 3x squared times negative 2x is minus 6x cubed. 3x squared times negative 1 is minus 3x squared. 3x times x squared is 3x cubed. 3x times negative 2x is minus 6x squared. And then negative 3x. Like terms here, we have a 3x to the 4th. Looks like minus 3x cubed. It looks like minus 9x squared, assuming you know what to add. And then take away 3x. Whew. One more to go. BRB. Alright, write the polynomial of least degree that has rational coefficients, which means that the first thing, the numbers are rational numbers. Leading coefficient is indicated, and whatever. Begin by setting up the factored form. Don't forget about the ugly root theorem. So the ugly root theorem is going to be right here. This is an ugly root. Use its conjugate to find the other one. A is 2, so your factored form is called f of x equals twice x minus 3. Remember we changed signs, x minus 4 This guy's going to be x minus 4 minus I. We change signs. Next one's going to be still x minus 4, but plus I when you change signs. And, not that I know what I'm doing here, but what I would do is I would do these two things and these two things, and then I'd worry about the 2. But what do I know? I'm going to FOIL this one out. X times x is x squared, minus 4x minus 3x, so minus 7x, plus 12. If you don't understand that, you've probably failed already. Still a 2 out front. I am going to, with this guy, make a big old box. It's just better at organization. I meant that. Like, you should know how to FOIL in your head by now. You're a junior. The only reason you don't is because you don't do anything and you blame somebody else for it. I'm so tired of that excuse. It's not that you can't do it, it's that you won't do it. I don't care who you are, you can do that. I've never encountered a kid who honestly could not. You just constantly make excuses about it's too hard. I don't understand. You poor little thing. Alright, so I know that I squared is negative 1, so negative I squared must be positive 1. Alright, let's see what happens. Gone, gone, gone. That's how this works. Lots of stuff disappears. We have an x squared, negative 4, minus 8x. Then we got a 16 and a 1 makes a plus 17. So I've done pretty good here. I've gotten down to this. Alright, next move here. Need another box. That is one issue with the box method. You need a lot of space. Alright, so I'm going to lay x squared minus 7x plus 12 down along the side. I'm going to go to work. X to the 4th, negative 8x cubed. That's a 17, believe it or not. 17x squared minus 7x cubed plus 56x squared. 70, 49. Lost my place. 119x and it's negative. 12x squared. Negative 96x plus 204. Double checking that one. $120, 70, yeah, 204. All right, so the nice thing about the box is, if you look at your diagonals, you got all these things that are like, they're not canceling here, they're just like terms. We have an x to the 4th, we have negative 15x cubed. Put our x squareds together, we got 56 and 29. I lost my place, sorry. 76 and 9, 85. I don't know what's wrong with me. 85x squared. Put those together. Negative 215. And plus 204. But wait, there's still a 2. So now, finally, just distribute that 2 to everything. And I know that this is, just too much work for you precious little things. But whatever. You don't have to make good grades, now do you? You don't. It is definitely grade level appropriate. I don't care if your parents say you'll never use it. They're probably right, to be quite honest with you. They are, unless you're going in STEM. But I mean, it's part of it, learning how to persevere. Anyways, there's your work. Hope you enjoyed.